Who? I might not have my volume turned up. I have my video on. Stop share.
No, you don't have your video.
Oh, I see. That guy. All right. Try again. Everybody online can see my screen fine.
Yeah, we can see it. All good.
They're still getting ready for getting ready in the morning. They just log in and they're in the shower. All right. So how did this homework assignment go? Easier, harder? Huh? It went better, but it was harder. Yeah, so isn't that so? The homework was harder, but it went better. So that means you're improving. I see.
I went from being like totally not understanding anything to understanding all of it because study groups are helpful.
That's right. But I get paid either way. I would. I got tenure. So,
Would you get like slapped in the wrist or anything?
if everybody failed my class, well, I mean, if I like unfairly failed them, you know, but if you like deserved it, like you failed because you didn't do the work and stuff. But I would say in general, I'm not like known to be like this overly horrific grader. I'm known to give a lot of homework and you spend a lot of time in the class, but I mean, I think I'm a pretty fair grader in the end. All right, what's the program we're using here? Dr. Scheme? Dr. Racket. Okay, this is the assignment, right? This product filter in. Okay. What's all that stuff? Ninja. All right, so let's look at this. First one, products. SOS1, SOS2, where SOS1 and SOS2 are each a list of symbols without repetition. This should return a list of two lists that represent the Cartesian product of SOS1 and SOS2. So if we have something that looks like this, ABC, and something that looks like XY, it should give us AX, AY, BX, BY, CX, CY. All right, so for each one of these guys, we want to map it into this guy here. All right, so what we want to do is we want to probably have two different functions. Helper function, one guy that's going to take in a single symbol and a list and create a, and I'll show you how you could do this without the helper function, but, and then create a list of lists containing this symbol and whatever each element of that list was. So let's write that little piece first. We'll work backwards. All right. So we're going to write something. So we'll define, I don't know, call it symbol merge, something like that. Actually, what I'm going to do is I'm going to call it product helper, just so, because I think when some people ask some questions, I referred to it as helper functions. Okay, so these like assist functions that maybe make life a little.
I didn't get that. Could you try again?
No.
Okay.
Yeah, I know. Oh, I saw it swirling up there. I've noticed that at least with Android Assistant, they've gotten a little mouthy these days. Like this morning, I asked like what the weather is, and they told me the weather, and they're like, "Oh, by the way, if you want to do these other 20 things, you can ask me." Just shut up. I asked a question, you give me the answer, then you go away. Well, that's fine. I don't need to. I mean, like, when I ask Alexa something, it's like, do you know you could ask me about the news? Like, probably. I ask you whatever I want to ask you. I'll ask you about the news later. You don't need to tell me a dissertation about it. I'm watching a movie. Like, I'll tell Alexa to like set an alarm. You know, so in case I fall asleep, it wakes me up, and then she's babbling on about other stuff. Yeah.
What are your views on Platonic?
Well, they're all the same crap. I think I've read something that really compared all of them to each other, and it seems like each one has like a very specific thing they're better at than the other ones. So the best product would be like the combination of all of their talents. Yeah, it works just like society. Yeah.
What's fun is when you take it, you get like custom messages that are like I don't like some of the videos like programming custom responses to certain statements.
Oh, right.
You make like the virtual assistant system is completely ridiculous.
Yeah, my wife's done that to mess around with me before. All right, so product helper is going to take in just a single symbol, because our idea here is as we go through that first list of symbols, we're going to be passing into that symbol, or passing in just a single symbol along with the entire rest of the list. We go back here, when we have this single symbol A, we want to create all of these, a to list with all of these elements, right? So I'm going to create just this helper function that takes in one symbol and our list of things that we want to merge it with. Make sense? And then we'll have our normal pattern if null list of symbols boil down to the empty list, because we're going to be constructing a list, right? All right, so we need our stopper case. Otherwise, we're going to cons the list version of symbol with the car of list of symbols onto product helper of our symbol with the cooter of list of symbols. So if we look at a little example of this guy, product helper, and we pass it an A and we pass it our X, Y, we get our list AX, AY. Make sense? So I've solved a little part of the problem. So now I ran to Home Depot, I got myself a tool. But now that I have that tool, it's going to make the rest of this problem a little bit easier to solve, right? All right, so now for product, I'm going to take in two lists of symbols. I guess they call them SOS, SOS2. And I want to process through every element of this first one and call my helper function with that second list and do something with the result, right? The something is going to have to make us choose, like, well, what are we really doing with this stuff? All right, we'll see that here in a second. So now we'll go ahead and we're going to define product to be a lambda that's going to take in an SOS1 and an SOS2. And what we're processing here is SOS1. We're applying our generic pattern to SOS1. So this is if null SOS1, then boil down to the empty list. Else, what are we going to do? Well, what we need to think about here is what the result of product helper is. So I'm going to go ahead and make my call to product helper. So I'm going to say product helper, passing it the car of SOS1. Along with the entirety of SOS2. And we know that that guy is going to give me a list of two lists. Make sense? That's what it's going to give me, a list of two lists. All right. And I want to do something with that related to calling product again. Let me just kick this down to another line. on the footer of SOS1 and the entirety of SOS2, which is going to ultimately give me some kind of list, finally ending in the empty list. But notice that I want a flat list here. So my first call to product helper is going to give me the list containing this guy. My second call will give me the list containing this guy. The third call is going to give me a list containing this guy. And I want all of those to meld together into a single flat list. So what magic function that we've learned can we use to take a bunch of lists and merge them together into a single list containing those elements? Append. All right, so really the trick on this guy was, which list construction tool do I need to use to give me the right output? Because you may have tried to do something like a cons, and then what you would have ended up having is a list of two lists. Kind of in a, all the right content was there, but it was like embedded weirdly. So when we use append, we're going to append that guy onto this guy. And now we should be able to call our product on A, B, C, and X, Y. And there's our list containing AX, AY, BX, BY, CX, CY. Am I still calling the, oh, I still have my helper being called. I'm like, what's that extra output? There you go. So that's product. Questions on, go ahead. Sure. Well, the most obvious thing to do it without a helper function is to literally take this and embed it right here. Well, I mean, this becomes a little messy, right? Because what I'm doing is I'm appending this function applied to these inputs. That function doesn't have to have a name, right? Now, something else you could do, let me think about this. This almost works for map. Single parameter across a list. Yeah, this will work. So I'm going to map lambda x list x is my element. Yeah, the limitation with map here is that map only takes one parameter, and I really needed to take two to use map. I could force it. I could, well, even, but then it's going to be extra work on the other side to make sure it gets called right. I'd have to pre-format my lists that I'm going to be mapping onto, so that I have the right values inside of there. So map is probably not the best use. So I guess the answer to your question is yes, you can do it as a single one, but why would you? Oh, sure. Yeah. All right. Yeah, and I put that in Slack. Some people had asked the questions, how can you do something? I said, writing helper functions like this is the way to do it. Just like if you're doing solving some problem at home and you need an extra tool, you run to Home Depot and you buy the tool. That makes the problem easier to solve. We created a tool here that allows us to make this problem easier to solve. Make sense? All right, so that's product. Next one, filter in predicate list, returns the list of those elements in list that satisfies the predicate pred. All right, so we have this list here and we're going to pass it a predicate. So something that takes one parameter, returns true or false. And we're going to, for instance, A is not a number. This guy is a number. So it wants us to build a list containing only the elements that match the predicate, right? The predicate returns true for. All right, so we're doing the same pattern where we're constructing a list. So we can start off with that, called what? Filter in, pred in list. Define filter in to be a lambda that takes a pred and a list. We'll ask our question if null list, then we'll boil down to the empty list. Actually, I'm going to do this as a cond because we really have three different steps, right? We're looking for the empty list. We're looking for things that do return true for our predicate. And then we're also looking for things that return false for our predicate, since we do a different ninja move for that. All right, so let's switch this to a cond. So we'll say null list boils down to the empty list. And you could choose to always use a cond if you never want to use an if, because you'll just have a cond with a single thing here and then your else. That's effectively an if statement in the form of a cond. All right, so if it's not a null list, then we want to ask if the predicate applied to the car of our list, if that guy boils down to true. You know, I don't need to say is true equal to true. I just got to say if this is true, then what am I going to do? I want to keep that element. So I'm going to cons the car, the car of our list onto whatever's returned by filter in, passing it the same predicate and the cooter of our list. Good. Right. But I get where you're going with that. All right. So, because we're going to end up having this in reverse. So the else here says this guy must be false. So I don't want to keep that first thing. So I'm actually just going to call filter in on the rest of the list. I have nothing here that I want to keep. All right. Now, as he pointed out here, I am building a element onto something that's returned by filter in. Now, filter in is guaranteed to return a list, correct? It's either going to be the empty list or it's going to be the result of this cons. So because this is going to end up building our answer effectively in reverse, I can reverse it later on, or I can cons whatever that guy is onto the list version of the car of our list. And that will take whatever this is and tack it on to that guy, creating a list. All right, then our example, filter in A213 B7, that's a number. Was it 13? So there's our, let's see. That guy returns the empty list. This will be a list. This will end up being a list. I think I could just append them. That's still backwards, right? So now I don't have to worry about cons putting it onto the front. So I'll just append the list version of this with whatever this guy returns. And that should give it to me in the right order. 270. All right, but the question he asked was a good one because it's basically saying, how does cons work? Cons takes an element and puts it onto the front of the list that's the second parameter, which would have effectively built our thing backwards. We would have had the right contents, right? But it would have been in reverse. We could have then reversed it later on. I think there might even be a reverse function. Reverse 27. Where did I type that? Oh. Just need to press enter instead of, yeah. So there's a reverse function. I could have just called reverse on the whole thing. Go ahead. Yeah. Sure. Yeah. But so there's two pieces there. It's yes to both things. Cons glue something onto the front of whatever is coming next. What you're saying is we have to wait for that value, which then waits for the next value, which then waits for the next value. We're still consing that thing we're waiting for onto the front of the next. Yeah, so cons is always going to take the thing that you pass first and put it at the front and create a new list that has that element as the first element and the rest being the list that came after it. Yeah.
So in this exact situation that we have, the first thing that is put onto the list is the 7. So put on 7
No. Because that will be my 2, right? As I'm going through this, I'm asking, is this guy, is this list the empty list? No. Is this a number? No. So do this. Then we're going to be stuck with this, the list containing this stuff. So we'll say, is this the empty list? No. Is this guy a number? Yes. So what do? We append the list containing that dude onto, so actually with this in mind, we could have just consted it. Yeah, that'll work. Yeah, we can use our normal construction. So we're going to cons this first element, not the promise of how did I get that first element, but the first element itself, the 2. We onto a promise, yes, but we have this value right now.
But it's not on the list yet.
Well, it is. This is a list in progress. So we would say in this case, this is the first call to cons, which will ultimately result in the front of the ultimate list. Because whatever the result of this cons will be, will boil down to the cons for the next part of the list. So we're consing a 2 onto whatever filter in boils down to for that. And then we're still consing that 2 onto whatever filter in boils down to that. Then we're consing on a 2 onto whatever filter in boils down on that, which is the list containing a 7. Right? Well, we're consing a 7 onto the empty list. So we'll get 7 empty lists, which is the list 7, and we're consing the 2 onto it. But that's the order it went in. We consed a 2 onto something. Now we have to wait for what that something is. So this original call to cons is going to produce a list whose first element is a 2. Because the rest of the elements are going to come later on is the second parameter of that original cons. All right, other questions about that one? All right, last one, list index. Pred in list returns a 0 base position of the first element of the list that satisfies the predicate. Pred, if no element in the list satisfies the predicate to the list, return false. Okay. So this guy's shouldn't be too difficult, with the exception. This is probably the one that drove some of the questions, right? I think I saw a question on Slack along the lines of, well, can I add extra parameters? Sure, through a helper function. Now, is it the end of the world if you just decide that, okay, well, my version of list index is going to take in a magical starting 0, you know, so I can do my counting thing? It's not the end of the world. But if you're thinking about this from a providing a tool to the end user, you want them to just be able to magically call list index, giving it a predicate and a list. And behind the scenes, under the hood, you start that counter with your helper function. All right, so we'll call this list index helper. And this guy is going to be a lambda that's going to take in a index, a pred, and a list. I'm going to call this guy curpos. I like curpos. That's a good variable name because this is the current pos we're looking at. And once that guy hits the number we're looking for, we'll finally be able to return the position. Otherwise, we'll just keep adding to it, right? So we want to return the 0th indexed, 0-based index in list. What's we call it? LST probably, right? That first fires true for pred, or a false if we never hit one. So we'll have our cond, we'll have our null, LST. If we've run out of crap to check, that's when we boil down to our false. I looked everywhere, didn't find anything that returned true for the predicate. Next thing is pred carve the list. If that's true, what are we going to return? Curpos. That's where I found it. Else, I didn't find it. So we're going to call list index helper. Oh, ninja. Passing it plus curpos 1. One more value down the list, along with the same predicate and the cooter of our list. Let's keep checking. So then our define list index will be a lambda that takes in a predicate and a list, and he'll call list index on 0, that predicate and a list. A2, oh, I can steal this guy. It's the first one we're testing, number. List index, number, that dude. And that should give us a 1. Bucket 1 was where the first number was. I'll just fake it for these other ones. If I say symbol here, we should get bucket 0. Simple predicate. If I say list, I'm going to get a 2, but then we'll fix that here in a second. I think, just so I don't have to change it, I'll just show you something else here. I think it's called a tuple. Current language. No, not called a tuple. No, because this guy's a list. Yeah, no, I already did that one. Yeah, I'm trying to give me my false. Oh, that's not the place you change it. You know that? I was testing you and you failed. Yeah, a lot. All right, there's our 2. So here, now we'll get our false. We'll just remove the list from it and we get our false. Good. Oh, this guy here? No, that we did finally hit it. Because eventually, oh, I see what you're saying. That's a good question. Because in this case, we didn't hit it, right? We got to a false. Why did they just put that in orange? Maybe it's like this is variable was never used. Kind of like in Java, you get that with Eclipse, you get the warning that this you only get the warning though if you wrote code that never uses the variable. Like, why did you use this variable? This was a waste of time. Yeah, I don't know. In this particular case. Okay, I could see that. Maybe I'm not sure how helpful that is, but effectively that means that we definitely did this at least once, and we definitely did this at least once. So this line never happened. I don't know how useful that actually is because we can kind of make that decision based on this, that we hit that. Oh, yeah, because I called them, right? Yeah, I don't know. It feels like maybe there was an intern and we was like, this was like week 2 or 3, and they're like, yeah, we don't know what to give this guy. So why don't you just make something orange? Just to get used to our code base. Yeah, go ahead.
Can you do this without having per pause and without
Do it without curve pause and hold the helper function. Well, you could definitely, well, you can map the predicate across the list, and that will give you a bunch of trues and falses. So for instance, if I call map, let's just do it for number in this case, number across that dude, that's going to give me a false, true, false, true. So then I can map another function across that. No, it's not gonna. I don't think so.
we have like a theory that maybe there was some way to like add the number of resources calls that take place. But we didn't.
You can always come up with when you find what
Mhm.
of it is, but that's not like
Okay, so I think the real answer here is based on what you know right now, the answer is no. You can create your own local environment. We're going to be looking at things called let stars and let recs. And let recs allows you to do a local environment that supports recursion. So then you could have a variable in there that does change. So you wouldn't have the helper function, but you'd have the same logic, you know, in there. So we're right back to what we had before, where it's like, hey, you know, when it's the same code. I could have it as a separate little pod that I might be able to use for something else, or I could just embed it inside of here. Yeah. Isn't that what this does?
Yeah.
That dives us out of the recursion, right? I mean, for most of our examples, we're somewhere in the middle of the list. Yeah. So something that, can you give me an example? No. So, okay, so I have a list of two lists. And what do you want to do? Well, I mean, isn't that the same answer? I mean, this guy is a conditional that's going to presumably, we're not dealing with the empty list. So we're somewhere during the process of the list and we have an opportunity to ask whatever question we want here. If we say, oh, this is the list, the two lists that it's our match or something like that, then we can dive out right then. So, I mean, this ends recursion. We only keep making recursive calls, and in our case here, until we've found our answer. Yeah, so I mean, understand that we don't sit there and necessarily process this entire list. We only process that list up until the point that we find our answer. If we never find our answer and we did process that whole list, this is our end case. This stops us from having an infinite, effectively an infinite loop, where recursion just goes on forever. Yeah, we could also, if we remove this one, then we would eventually just have a crash, because we would try to take the car of the empty list, which the scheme is not going to be happy with. All right, other questions? Go ahead.
So is that just like a basically poorly written question where it shouldn't just allow us to make it different size rather than having us write two separate questions?
I don't think so. And for the same reason I said a few minutes ago, where if you're thinking about providing a tool to somebody, behind the scenes, you might need a counter to make it work. But why should the end user need to throw some extra arbitrary value in? Because they might throw the wrong value in. They might start their count at 2. And all of a sudden they're getting the wrong result because they, put, regular fuel in instead of fuel mixed with oil. Like in the lawnmowers, you ever tried that? Get a lawnmower just won't start because you didn't put the oil in there. You didn't do the mix. Yeah, well, yeah, some places have that. But most of our modern gas stations, like if you go to like a Citgo or something, they're not going to have a pump for 2-stroke. They're going to have normal gasoline, and then you got to go home and you dump the oil in it and you mix it up, and now you have for your weed whacker or whatever, your lawnmower, now it'll run. If you don't do that, you're like, well, my car works with the same crap. You just sit there and you just pull the cord. Then you hire a student to come in. This is not autobiographical, but this is autobiographical. It is. I didn't know how to do that. I've never had to mow my lawn. Come on, people. We're right back to the first world problems. I've seen it like on a TikTok video where they start in the middle and then it works its way in. So it starts out in the outer skirts. You have a long rope and it's a pole in the middle, and it just starts going in circles as the rope wraps. The lawnmower gets closer and closer. You need one of those auto push, lawnmowers that go on their own. Like, I think it would be cool to do a riding lawnmower for like, like 2 times. Just to say you did, but then you're just better off paying somebody to do it. I mean, that's why you've gone into computer science, so you can afford to do that. I mean, your time's worth more than that, right? This is like, well, okay, I can go mow the lawn. That's well, some people enjoy it. Same thing with like gardening. You could say, well, which is more efficient, having your own garden or just running over to Sendix and buying your fresh vegetables? Well, Sendix is going to be more time efficient, but some people really enjoy gardening. Same thing, fishing. You can go out and catch your own fish, or again, you run over to Sendix, you just buy the fish you want to eat that night. I do both. I go fishing, but throw them back because I like listening to my audiobooks while there's the peacefulness of fishing. But I'm not eating what's coming out of the Milwaukee River. I caught a bass one time that had 14 eyes. What were you saying something?
Why be outside in the room for all 20
Well, no, I like outside. I just don't want to be doing, like manual labor.
I like outside. I was trying to.
Yeah, but I mean, so we want to, our professions, our vocations should line up with our, let's say, our worldly desires. And then you decide what's the best use of our time. We all have time and talents that we contribute to, church and society and things like that. I mean, there's a guy at our church who mows the yard. He likes doing that, and he's good at doing that. Even if I liked it, I wouldn't be very good at it. There'd be long strips of missed spots, and then you have some old lady probably complaining about it. It's like, oh, the lawn's not mowed right. Well, Littman did it. Oh, that makes sense. That makes a lot of sense. All right, so that's the homework answer crap. Oh, I gotta start. Nailed it. Okay. Oh, still no 3-star. Okay, so some more examples. So we have a function called every that returns false if any element of our list fails to satisfy our predicate and returns true otherwise. All right, so we're going to process through our list, pretty similar to what we just did in the previous one, ultimately returning a false if any one of these elements fails this predicate. Otherwise, we're going to return true. All right, so it's called every. We don't need a counter for this one because we're not returning anything. So we'll define, we're not counting positions or anything. So we'll define every to be a lambda that'll take in a predicate and a list. And we'll ask, is it the empty list? If it's the empty list, that means I've checked everything in there and I haven't bailed out yet. That means I went through every check and it passed every check. Therefore, every one of them must have met the requirements of my predicate. Go ahead.
So I know, like, no question mark for check on something. Is every question mark?
Anything with a question mark after it, by naming convention, it's not a requirement, but most of the built-in functions that have a question mark at the end of it are called predicates, which are functions that take in a single parameter, return true or false.
Okay, so like every is the same predicate as well.
They're having us rated as a predicate. We're inventing this.
So you're creating a predicate.
It doesn't, I mean, I could call it that if I wanted to. Yeah, nothing says it has to have the question mark at the end of it. It
But if
just
you're-
happens to be that usually if you see a function that has a question mark, it's probably a predicate. So we're just following that same standard.
So are you intending to make it a predicate then?
Well, actually, it's in this case, it takes 2 parameters instead of 1. And I guess I'm not intending anything. I'm just answering the question. But yeah, I would say, yeah, it's a predicate. You know, we're passing it some stuff that ultimately is going to boil down to true or false.
But this is like-
No, these are good. But this is very similar to the argument of like in Java, when we create our own classes, we typically use uppercase letters to start the class. Not because Java cares, because typically when we see something that's capitalized, that's the name of class. That's a naming convention
It's so
in,
different than, like, C stuff, so.
it's not really, it's not really different. If you keep telling yourself it's different, then you're gonna keep freaking out. Well, that's what I'm saying. So it's at this point, you're ignorant of it because you haven't had the experience. But at the end of the day, you're gonna see the patterns line up the same. And you're already seeing the second homework assignment you said went better than the first, even though it was probably 4 times harder. It was a lot harder assignment, but you were better at scheme because you've already had semesters and semesters of programming. So you already know how to program. Now you're just saying, okay, you've thrown me this tool that I'm not used to. You're figuring it out, right? All right, so every takes in a predicate. If I'm out of stuff to check, that means I passed every checkpoint, and I'll go ahead and return true. They all met it, because that's what every does. Every returns true if every element of this guy returns true for that guy. So if I've run out of elements to check, I'll go ahead and return true. Otherwise, if pred, when applied to the car of our list, is true, then we can say, so far, so good. And then what do? We call every, passing it the same predicate and passing it the cooter of our list. Let's keep going. I can't say that everyone has matched yet, but I can say that the first guy returns true for our predicate. Okay, now our else means I found something that didn't return true. So I'll boil down the false. Yeah, this is the yeah, this is the literal Boolean true. This is the literal Boolean false. In Java, this would be written as true. This would be written as false. They're equivalents to each other. That's just the scheme syntax for trues and falses is #T, #F. All right. So what are examples? Number ABC3E. All right, we think this one should return false because definitely not every one of those guys returns true for the number predicate. Similarly, every 1, 2, 3, 5, 4. Should be true. They're all numbers. Was really a 2-star? Hopefully your homework has a 3-star. No, not yet. Oh, merge sort. That was in my head, I thought. then it wasn't. That's great. It's actually just half of merge. It's the merge portion of merge sort. We go right back. Didn't you write merge sort? You wrote it your first semester, which was terrifying. And then you wrote it again and it wasn't as bad. The scheme's easy. There is actually kind of a trick to it. You're going to try to do it the hard way. And it's going to take you, I don't know, 30, 40, 50 hours minimum. If you haven't already started, it's going to be late. I'm not assigning it till next week. Oh, man, it's so much joy. I don't know. No, you'll have a weekend because isn't the next one? Yeah, it's gonna be homework today,
Oh, I thought.
but the next one will be.
No,
We did.
next one, so that's 27.
Oh, look, I'm gonna do merge in class. Well, we'll see. If I don't get to it, you're doing it. Should just take my time and enjoy my coffee. Really slow things down. All right. That didn't really feel like a 2-star though, did it? Didn't that feel pretty easy? Maybe we're getting better at this, you think? Interesting. All right, so exists returns true if any element in the list satisfies our predicate, returns false otherwise. Define exists. It'll be a lambda, takes a predicate and a list as a parameter, and we're going to return true if any of our elements returns true for our predicate. So we'll have our cond, null, list. If I'm still kicking, that means I've checked every single element in here and none of them return true. Yeah. That's a good point. So you could actually just call not every. So the whole answer to this one could just be not every spread list. That'll accomplish it. But that presumes that you already own this tool.
Yeah, I was.
Yeah, no, but I mean, that's a good mentality. If you already have that tool, then you can solve the problem in terms of that tool. Absolutely. But let's keep going so we keep seeing our pattern. So if I've run out of crap to check and my predicate returned, and I'm still kicking, that means at some point I didn't bail out. At some point I didn't find something that returned true. So I'm going to just boil down to false. Otherwise, if pred, when applied to the car of our list, is true, then I can just boil down to true. I found one. This function only requires I find one. I found a single element in this list that satisfies the predicate, so I'm done. Else. Haven't found my answer yet, but that doesn't mean that all hope is lost. So what are we going to do? We're going to call exists, pass and get the same predicate and the coder of our list. I'll just steal one of my things from up here. So exists, we'll pass it our number predicate, and we have a whole bunch of symbols in here, but it does hold true that there is one element in here that exists that returns true for number. So our last thing here should be a true. There's our true. If I take that 3 out, now it'll be a 4, or now it'll be a false rather. All right, questions about that? All right. Up removes a pair of parentheses from each top level element of our list. If a top level element is not a list, it is included in the result as is. Didn't we already write down? Is that a previous assignment? Yeah, right. So this guy's referencing down. It's saying that up, down is equivalent to just the list. Up undoes down. That's what this is saying. The value of up, down of list is equivalent to just a list. Okay, so if we call up on the list containing these two lists, we end up with a single list 1, 2, 3, 4. All right, so what we want to do is we want to remove parentheses from a list. So how do we do that? If I just have, we're going to start with a small example here. If I have just the list 1, 2, how do I remove the parentheses from that? Go ahead. Okay. Go ahead. So we would start consing the contents. We're going to process that to list, consing the elements onto an empty list, building it up. So if I took the list containing the list 1, 2, and I consed this 1, 2 onto things, I could then build a list. Now, what would happen theoretically here if I appended this list onto this list? I get the right answer? And there's one case, but append would actually accomplish what I want. Now, only if I'm dealing with strictly lists. Now, what if I had a situation like this, where I had the list containing these guys? Now, it only wants me to remove one set of parentheses. So I don't have to go in and remove the second level. So I could still say I want to append this guy onto some modified version of that guy to get the right answer. So it wants me to leave non-lists alone. But if I'm using append as my tool, shouldn't I make a non-list a list? So I can define up to be a lambda that takes, what is this guy taking? Just a list. A list as a parameter. And we are going to have a cond. We'll say null list should boil down to the empty list. We'll say list of car list. If I'm looking at something that's a list, I'm going to append the car of list onto whatever up returns for the cdr of list. Else, I must be looking at not a list. If I'm looking at not a list, what will I do? I will append the list version of the car of list onto the up of the cdr of list. Go ahead.
So append requires that those parameters are listed.
Yep.
Even if it's just a list.
Even if it's a one list. Oh yeah, or the empty list.
So you're making the car view list. You're making the car.
I'm making it a list. That way, when I append it, it becomes the contents of, it just becomes the thing.
Oh, in the else statement, so that car view list.
All right. So we test this dude. List 1, 2, list 3, 4. Up. That should give us 1, 2, 3, 4. Test another one. List. Man, that's too many parentheses. Don't you hate these parentheses by now? Up. List. The list X, the list Y. Let's see. There's our X list Y, Z, X list Y, Z. All right, so that's up. All right, questions on that one? Go ahead.
What is the list
Oh, just showing us that we are looking at something that is a list. It's, I guess, visually flagging it as a list. It's possible that one of the languages would end up having this, not having the word list in it and just having a parenthesis at the beginning.
How did you make it like say that? Well,
Oh, if I display it, that'll do the. Yeah. Nailed it. But I still stand by. There might be one of these languages you can pick that might have that as the default. But this is, I mean, this is the right answer. This is something that is a list, and it's the list containing these things. All right, other questions on those? All right, so there's some more examples. All right, let's see what's on this next thing. What's this? All right, here, let's look at merge first. Since I've assigned 1.27 officially, but I might have you do merge. All right, merge takes in two lists of integers that are already assumed to be sorted in ascending order. So this returns a sorted list of all integers in list of integer 1 and list of integer 2. So notice here that this is already post our merge sort call, our sort calls. So we have a partially sorted list here. This is already in order, and a partially sorted list here. This is in order. And ultimately, we want to merge these guys together. So this is that step where we say, who's the winner, 1 or 1? Doesn't matter which we pick, it's 1. Who's the winner, 4 or 1? It's 1. Who's the winner, 4 or 2? It's 2. Who's the winner, 4 or 8? It's 8. And then we're out of stuff, right? All right. So that's what merge takes as a parameter. So what do you think? You want me to write it, or do you want to have it for homework? I think it's probably the arrows themselves. Greater than, because it really actually isn't bad, and it has an interesting trick associated with it where you're going to try to do it the hard way. How about I just give you the hint for the trick? That sound reasonable? All right. Now, as I just talked through it, if we were writing this in a traditional language, we would probably keep track of where we are in this list along with where we are in this list. And we would be comparing our answers based on this index and this index. So who wins, bucket 0 or bucket 0? Who wins, bucket 1 or bucket 0? So on and so forth. You could write it that way. Or really, aren't we just whittling down these lists? We want to keep going until this list is the empty list and this list is the empty list. So if neither of them are the empty list, we want to compare their cars, right? If one of them is the empty list, we're just going to keep the car of the other one. If both of them are the empty list, we're done. So we're going to have that same pattern. That is, if I'm dealing with a null for the first list and a null for the second list, if both of those are true, this is using the and if null this guy and I'll just like force it and null that guy. If both of those are true, the whole thing's true. But if I had a 2 here Now it's false. Even though this first one's the empty list, this second one is not the empty list. So that's false. So what you're going to do is you're going to add multiple questions to your cont. Are they both null? If yes, boil down to the empty list. Otherwise, at least one of them is not null. So then you might ask, if the first list is null, boil down to the car of the second list. And then make your recursive call on your empty list, the cooter of the second list. If it's the second list that's null, boil down to the car of the first list, and then make your recursive call with the cooter of the first list and the second list. Otherwise, they both must be non-empty. So now you're going to start a secondary list of questions. So it'll be a nested cond or a nested if statement. You know that they both have stuff in them. So now you're going to compare the cars. If the car of the first one is less than the car of the second one, boil down to the first one and make your recursive call on the cooter of the first one with the entirety of the second one. Else, boil down to the car of the second one and make your recursive call on the entirety of the first one and the cooter of the second one. Make sense? I just verbally said the entire solution. So now you need to turn it into code. And none of it's hard. You're just going to have a more complex looking cond. You're going to have a cond with 1, 2, 3, and then 4, 5 steps in it. Just more questions we're asking. All right, questions, comments, concerns, bribes. All right, so homework for Tuesday is to do both of these, 1.27 as well as 1.28, remembering that at the end of this video is me talking you through 1.28. I would encourage you to try to do it on your own first. Otherwise, try to write the code along with my verbal algorithm. Yeah.
So Platinum is doing what we did with up, but for every list inside, that's right?
Yeah, it's a recursive flatten. Yeah, it's a recursive up. So what he's saying here with flatten is every single one of these lists ends up getting flattened. You can if you want. Yeah. He asked, can you use up as part of your answer? You have the tool. I mean, effectively, that's a helper function, right? You can write it again, or you can just include it. All right. I will see everybody on Thursday. Front Row Club in Chapel. I'll save a seat for you, unless today's matins. Today matins?
I don't think so.
Okay. Oh, I like Professor Doug.
They're rotating. They match up a lot this year.